All right, guys, let's do it. All right, to follow up on the last, let me try to get organized here and see what we want to do. I think the game plan here is let's work with this new data set. It's called Quality of Life. Obviously, you'll have access to it. Just to give you an indication of the variables. I don't know what the sample size is. Let's just look at, I don't know, university. So sample size is 276. All right, that's cool. So it's my understanding of this data set that what they did is they gave a quality of life pre-assessment, and then they did a quality of life post-assessment. And it looks like, let's just examine UNIV. It looks like there were, oh wow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 universities that these students were nested in. Looks like they were either in a STEM major or they weren't. They had intent to attend grad school or they didn't. This is their age, gender, and BDI. BDI is some sort of inventory assessment. I think it maybe has to do with the depression score. You can Google it. I just didn't make it up. In fact, I stole the data set. But I've already tinkered around with it a little bit. Guys, after you watch this video, you're probably going to be like, well, why do we do the other stuff? Because this will be a very thorough illustration of what I want you to know and what I want you to be able to do. So guys, we're going to run through is a mixed model even needed? Just go ahead and be very transparent here. I've already looked into that and it is needed. So we're going to run through the analysis step by step. I'm going to include a lot of hashtags to tell you what I want you to know. I thought about creating a PowerPoint with all the narrative, but someone told me one time that they preferred this. And then in the end, we'll actually access the write-up, and so it'll be a complete example. So let's talk about the goal here. We can really make the goal whatever, but I'd like to predict quality of life post using quality of life pre as a covariate. I want to use, let's see, UNIV, STEM. What do I want to do here? Let's think this through. What would be something to be kind of cool to do? I don't want to use all the variables because your homework assignment, your discussion forum post is going to use some of the others, but I haven't decided yet. I'll tell you what. Let's just analyze, STEM, grad school. We'll leave these three over here for an assignment. But let's look at STEM, grad school, and then let's look at STEM, grad school as an interaction. So these things will be used as a fixed effect, and the random effect here will be UNIV. All right, so that's what we're going to do. So again, the very first thing that I'd want to do is I want to run the intercept only model. Guys, I have that right back up here, so I'm going to use that. So my dependent variable here is quality of life post, and I really don't need the summary. So let's go up and grab the random intercept only command, and I want quality of life post, and my nested, or my random effect is UNIV. So I can run the ANOVA. Kind of lazy here, so let's just go up and get it. There we go. And you can see as I kind of let the told you we were going to get. The p-value is less than 0.05, so the random intercept model is an improvement over the intercept-only model. Now, guys, what I would want to do here, I would report this as chi-squared. The degrees of freedom will be the difference in the df, so 3 minus 2 is equal to 1. Equal to the test statistics, which will be the L ratio of 107.65. Just be consistent with rounding. I don't care how you round. And P is less than 0.001. Concluding that the intercepts vary significantly across different universities. In addition, notice I didn't point this out, but this is something where I always have kind of tunnel vision, and we would need to run the summary of the two models, and I did earlier in preparing for this video. All right, so guys, let me show you that. All right, so our AIC in the null model was 2017, decreased to approximately 1911, and the BIC 2024 decreased to 1922, indicating a better fit. All right, cool stuff. Now, let's add in the fixed effects. And what I want to add in as the fixed effect, what would be kind of cool to do, I really haven't done much from here. I think it'd be kind of cool, obviously we want to do quality of life pre, and I think another cool would be, let's do STEM, just to make a point. Now, in a previous video I told you that if we have a categorical variable that, if we have a random effect, it must be a categorical variable. But a categorical variable can also be a fixed effect. And in this case, it makes sense that it is a fixed effect, or at least it can be treated as a fixed effect. So, enough of that. All right, so let's add in the fixed effect. So I'm just going to call this model. So I'm going to run the LME. Sorry, my cat has me has got me distracted. I should say my daughter's cat. STEM, and let's set the always have the hardest time finding the vertical line. Let's set the UNIV as the random effect, and of course method, we need to be consistent. All right. Okay, well, this is fun. What happened? Oh, okay, I see what happened. Had a bozo moment. All right, so first thing I look at, tunnel vision. I look at my AIC, notice decreased, indicating a better fit. BIC decreased, indicating a better fit. And so I would probably want to explore that just a little bit further because I know what I'm going to get. So I want to compare my model with my random intercept model. Rand intercept only. Oops. All right, so again, lesson 0.05. So the throwing in the fixed effects of stem and the covariate actually indicates a better model fit. Now let's provide a little narrative here about what I look at when I see this output. First thing I would say that the regression coefficient. You know, when I run a mixed model or multi-level model, I still have tunnel vision on my predictors, right? But then we have also added information about our random effects. But I still have tunnel vision on the p-value of my predictors, and I can see that the regression coefficient for stem, which is negative 0.31, which by the way is not significant, indicates no difference for STEM and non-STEM students. However, the baseline quality of life, the quality of life that the assessment provided before they began. And I don't know if I put this into a proper context or not, but it's my understanding of this data set, let's go back up to head, that this was taken at the beginning of the first academic year. So let's say probably around August, and then quality of life post was taken in May or June at the end of the first academic year. That's my understanding, but I can't confirm that. So baseline quality of life has a regression coefficient of 0.48. And this would be reported as T degrees of freedom 264 equal 9.07. P is statistically significant at the 0.001 level. All right, now let's add in random slopes. Let's see if the slopes vary across the 10 universities. So I'm just going to call this Model 2 because I'm really not that creative. I'll tell you what, let's just go back up and get Model, and we can just make some modifications to it. So I want Model 2, and I want to slide, let me make sure I get this right. So I want to slide random, okay, so I want to slide stem as a random effect. And Model 2, let me make sure I had this correctly. Correct. All right, cool. So let's see if we made an improvement. Again, just looking 1842 versus 1812, 1865 versus 1837, and of course 918, well, not 19, 900, call it. So it looks like that there is statistically significant, there is an improvement. So I want to kind of confirm that. So I want to go Model and Model 2. So we can confirm that introducing random intercepts into the model produces a better fit. All right, so let's what will be the appropriate narrative on that? So I would say about by allowing STEM to vary across universities. The AIC, BICs decreased. And I would report that as chi-square. Degrees of freedom, so 7 minus 5 gives us 2. Aren't you impressed that I can subtract? So 38.87. statistically significant at the 0.001 level. So this indicating that adding random slopes to the model has significantly improved the fit, meaning there is a significant variation, or variability I should say, in the effect of being in STEM or not across universities. All right, so that's what it tells us. Now, we can dig a little deeper. So the relationship between STEM